Welcome everyone to my LeetCode weekly contest 436 live stream. If you're here for solutions, jump ahead to 90 minutes in or use timestamps in the video description. In a few minutes, we will be doing the contest live. We'll be answering questions and giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared while the contest is running. We'll never share code on this channel, but immediately after it ends, we will go through solutions for all 4 questions. So make sure you stick around. If you enjoy LeetCode contents, do check out the rest of my channel. I have videos on different problems as well as the hardest question 4s from previous contests. And as usual, like and subscribe to stay updates on new videos. All right. I see some people in the chat already in the channel already. So welcome. We are about to start in about 5-6 minutes. So hang on to your hats. Hi, Code with Zen. How are you? I don't know if I recognize your username, but if you're new here, welcome to the channel. Welcome. We don't. I should probably put this in the chat. We don't share code during contests. Go over answers after it ends. Yeah, as usual. We don't share code during contest, but we'll go over everything after it ends. So today's contest, waiting for it to start. Hopefully it doesn't DDoS us again. While we're waiting, let me just check out what I did for my last contest. It's not great. I'm trying to get back to 2000. 1992. I need to get back to 2000. My peak rating was 2000 plus. So I need to get I really need to get back 2000. I think it shouldn't be too difficult. I've gotten to 2000 before by doing some contests off stream. So off stream is a lot easier because I don't have to talk. I don't have to discuss anything. I just work on my own problems. I can use any IDE I want. So off stream is a little bit easier. I'm trying to synchronize my setup so that my on-stream results can also improve. But we'll see how it goes on that. Let me see. In the meantime, today's problem of the day is it's actually pretty interesting. I don't have it here. Well, yeah, today's problem of the day is pretty interesting. This is like a standard contest question kind of deal. There's some math to it. If you've not tried it out, make sure you try it. If you've not tried it out, make sure you try it. This is a pretty interesting question where you're asked to find indices. You define what a bad pair is, and then you find indices. And as usual, I feel like this kind of questions, the trick is to sort of understand the math behind it. If you can figure out the mathematics behind it, it's not super hard to get the right answer. Okay, so a few more minutes before the contest starts. Hopefully more people show up. It really depends on the night how many people I show up. It's iffy. But we'll wait a while and see what happens. In the meantime, I'm actually curious. I've never actually done this before. So I see a lot of like anonymous posts on the front page of LeetCode. I've never actually looked at them before. So I'm curious what they are. So let's see. Let's look at them now a little bit. This one says meta interview. And this guy basically talks about his experiences working, I guess, interviewing for Meta and what kind of question they ask. I'm curious. I've never actually interviewed for Facebook or Meta before. I just did one interview with one company. I got in and stayed there for 10 years. And I never really interviewed elsewhere. I haven't interviewed for a very long time. I'm sort of curious if the interview meta has changed. The sort of meta gaming of interviews have changed over time. Let's see. Valid palindrome 2 follow up. Valid palindrome 3 just ask for a signature of recursive call. Coding. Merge two sorted interval arrays. Given two sorted non-overlapping interval arrays, return a third interval array. There's a union of the input interval arrays. Okay, this is quite easy. So you just sort them by start and end. You sort them by start, and then you figure out who else starts before your end, and you just combine everybody else together. City generator. Okay. Well, it's about to start. Let's go back to a tab. All right. We're going to start in 10 seconds. Good luck, everybody. So once again, as a reminder, I don't share my screen during the contest because, it is a contest. So you got to have competitive integrity. Yeah, but I will talk about the problem. You ask question in chats, I'll try to answer you. But my point is, if I don't seem to be doing anything on screen, don't panic. Something is happening. Okay, interesting. Question 1 is a medium. We'll see if it's actually medium. Your n by n square matrix of grid. Return metrics such as diagonal in the bottom left triangle, including the middle diagonal, are sorted in non-decreasing order. Diagonals in the bottom left triangle. Oh, wow. And then the diagonal in the top right triangle are sorted in non-decreasing order. Okay. So basically, so basically we're dividing the this guy into two. We're dividing a square into two. We have this one. This is the bottom right triangle, and then this is the top right triangle. Bottom left triangle and top right triangle. So the diagonals in the bottom left triangle are sorted in non-decreasing order. So it's like this, this, this. And then here is this, this. Okay. Okay, cool. And then I guess you're allowed to move them around. You're allowed to move them around. Bottom left as non-increasing order. Oh, sorry. So it's the other way around. So this needs to be 861 largest to smallest. This is 95 largest to smallest. Okay. And then this is the other way around. Okay. This is not super hard. I think the only tricky part about this question is actually figuring out how to extract the diagonals, which is non-trivial. But once you figure out how to extract diagonals, it's not that hard. I can see why this is a medium problem, and I am appalled that it's worth 3 points only. But then again, we'll see how it goes. yeah, again, I'm gonna just code here, so I'm gonna be a little bit quiet. Hmm. Excuse me. Once again, if you have questions, just ask in the chat. I will try my best to help. Output 1, 3. X95. Okay. 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 All right. Question 1 done. Okay, let's look at question 2. Oh, nobody's asking question. Tonight is a very quiet chat. I hope that's not a bad sign. I hope that's not a bad sign. I hope people are actually around. Valentine's Day is around the corner. Alright, question 2. Assign elements to groups with constraints. You're given an integer array groups, where groups I represent the size of the ith group. You're also given an integer array elements. Okay? So your task is to assign one element to each group based on following rules. Okay, so you're given a bunch of numbers and you need to you're given a bunch of elements and you're given a bunch of groups. Okay. An element j can be assigned to group I if groups I is divisible by element j. If groups I is divisible by element j, if there are multiple elements that assign the element with smallest index. If there are no elements that satisfy the condition of a group, assign -1 to that group. Okay, so let's see. So the groups are 8, 4, 3, and the groups are 8, 4, 3, 2, and 4. Okay, the elements are 4 and 2. So an element j can be assigned to group I if groups I is divisible by element j. So if groups I is divisible by element j, so this is divisible by 4. So wait. Oh, sorry, it's divisible by 4. So we have the index of 4, which is 0. Four is divisible by 4, so again it's 0. 3 is divisible by no one, so it's minus 1. 2 is divisible not by this, but by this, so it's 1. And then 4 is again divisible by 4, so it's 0. Okay, so this is pretty straightforward. So the only catch here is these are I'm guessing the numbers are, the sizes of these are pretty large, right? The sizes is okay, 10 to the power of 5, 10 to the power of 5, which means that if you want to do this like in n square time, that's going to be too slow. So you need to find out of this, basically for each item here, you need to find the first element here where this guy is divisible by. That's the game that we're playing. So 8, if it's divisible by 4, actually, I don't know if it's actually that slow though. I don't know if it's actually that slow. So you want to find the... Okay, this is also 10 to the power of 5. So you want to find the factors of this guy. It's not that... Yeah. Let's see. Let's see. We can do it by brute force. I wonder if brute force is enough to solve this. Because brute force will make everything much easier. You just take each element, you look up. Yeah, maybe brute force with some caching. 8, right? You sort of look up what are the numbers I've seen before. Yeah, maybe brute force with some caching might work. Let me try it out. Yeah. Brute force with some caching. If it doesn't work, then I'll come back to it. No harm, no foul. Also, elements is not sorted, so elements can be really weird. But I don't mind it being weird. Okay, let's try by brute force and see where we get a land. Oh, this is a very quiet night. I wonder where everybody is. So results. I'm gonna try by brute force with some kind of caching. And I wonder if this is enough to work. I don't think it's gonna work. I honestly don't think it's gonna work. Hmm. 1 0. Okay, let's see if this works. Oh, nope, doesn't work. Yeah. Yep, doesn't work. Yep, Sriram Rajkumar. Yep. 565 out of 572. Yeah. The last few ones are really, really big. So without caching. So maybe instead of caching. Yeah, I hate this kind of. Yeah, I kind of hate this. So without caching. What's another way of doing it? Probably another optimization. Like, I feel like one way to attack this is by optimizing the solution. The other way is try something radically different. So one thing I'm thinking of right now is if I go through these elements, and then for each element I check if this element is a factor, is a multiple of a previous element, then I will skip that element. That's one thing I can do. Yeah. So like 4 and 2, right? If it's... So let's say if it's 4, 2, and then like 8. 8 is a factor of 2, and it's a multiple of 2 and 4. So whatever is divisible by 2 or 4 is also divisible by 8. So 8 will never be used. So we can skip this. So that's another thing we can do. But the thing is, like, yeah, but the thing about that is like, it's kind of whacked, you know. So that's still a heuristic. So I don't know how much this will help. So the other way I'm thinking of is like a tree-based solution where each is like prime. But I don't know whether this will help. Okay, you know what? I'm gonna come back to it. I'll look at the other ones first. Okay, question 3. You're given a string S consisting of digits. Return the number of substrings of S divisible by their non-zero last digit. A substring is a contiguous non-empty character within a string. String may contain leading zeros. So 12926. We define substrings that are divisible by their last digit. Substrings that are divisible by their last digit. So let's see. So first of all, 1, 2. 1, 2, 4, 5. 5 are special. These are sort of special. Oh, actually 8 is also special. So straight away, the first thing I can think of is another heuristic, but maybe is the right way. So 1, 2, 4, 5, and 8 are special. So, you know, if the last digit is 1, then it's always divisible. If our last digit is 2, if you see a 2, then basically everybody is divisible. Yeah, divisible by 2. You see a 4, if something ends with a 4, you only need to see the number before it. You just check the number before it. And if the number before it is is there wait a second. So how many substrings? Okay, this is so 29 divisible by their last digit. So how do you know if a string is divisible by their last, if a number is divisible by their last digit? So if it ends with 1, then every number is divisible. If it ends with 2, then also every number. If it ends with 4, you check the previous. If the previous digit is like is either, if the previous is what? Is 0, 2, 4, 6, or 8, then it's divisible by 4. If it's 5, any number ending with 5 is every number ending with 5 is divisible by 5. What about 6? 6 is tricky. 3, 6, and 9 are tricky. 3, 6, and 9 is tricky. You have to sum the digits, right? You have to sum the digits. 8. Last 2 digits. And then 7. Are there any numbers ending with 7 that's divisible by 7? Oh. I think 7 is tricky also. Yeah, 7 is also going to be tricky. Okay. So I think there's a bit of heuristic. If it ends with all these digits, then Basically, it's a sliding window problem. It's a sliding window problem. Almost like a sliding window problem, I think. So S length 10 to the power 5. Yeah. So 32. Yeah. Yeah. Correct. You're correct. So basically what I'm saying is that you have to check the last 2 digits. Wait, what do you mean? 32 is divisible by 4. Yeah, 32 is divisible by 4, but 32 doesn't end with 4. So I'm talking about all the numbers that end with 4 and are divisible by 4. So for a number to end with 4 and is divisible by 4, it's going to end with 0, 4, 2, 4, 4, 4, 6, 4, or 8, 4. So 32 does not end with 4. $77. Yeah. Hey, Maddox. Yeah, creating a race. That was my idea also, but it also fails. That kind of sucks. Okay, so let's see. So 3, 6, and 9. 3, 6, and 9, I think is you need a running total, right? Isn't it the rule? If the sum of the digits is divisible by 3, 6, or 9. Yeah. How do you know if you know what? I'm gonna I'm gonna check. How do you check if something is divisible by 7? I feel like there's some trick there that I'm not seeing. Yeah, if the sum of digits is divisible by 3, if the sum of digits is divisible by 3, then it's multiple of 3. If the sum of digits is divisible by 9, then it's a multiple of 9. If the sum of the digit is, so for 6, you check whether it's divisible by, yeah, 6 is basically always. So I guess we have to, so for this, okay, 7 is the only one that I don't know. So for this, basically, you do like sum, right? You keep track of the running sum of the digits. Oh, but you cannot do that easily. And you check how many of them are divisible by 3 and how many of them are divisible by 9. Okay, so basically for this, you create like a mod table. I think what you do is you do a mod table. You count how many digits are there before it. Okay. So the only thing I don't know is 7. The only thing I don't know is 7. Yeah. So basically what you do is you go down the list. When you see a digit, you check something, you know. Like let's say you see a 2. You're at index 1. You're at like, let's say you're at like you see 1, 2, and you're at here, so you know the number of contiguous guys that can divide by 2 is going to be yourself, just 2, and then 1, 2, so ending with 2. Yeah, so you do this, so this one you need to check the sum. Yeah, this is the only one I don't know. This 7 is the only one I don't know. 7 is the only one I don't know. So how do you check if a number is divisible, ending with 7 is divisible by 7? So to check that, double the last digit and subtract it from the rest of the number. Yeah, but the thing is, yeah, so that works. But the thing is, if it's like 77777 1,000 times or 10,000 times, this is going to be super slow, because now we have to check this 7. I have to check like 77, the one before, and 777, the like 3 sevens. I have to check a lot of numbers. That's the problem I have. Yeah, that's the problem I have. Or maybe I can have a mod, right? I have a remainder 7. I have a remainder 7. How many numbers? Maybe I have a mod map, is what I'm thinking. So for 7, let me see. They are more time than normal mod. So the reason why they are faster is because, okay, let me explain why they are faster. So let's say your number is 246824, and you are here, okay? Let's say it's a super long number, like 1, 2, blah blah blah. There's 1,000 digits before you. You are here. You want to know how many numbers. This is contiguous substring, right? How many numbers ending at this digit are divisible by 2? So your index is, let's say, 1,000. If you want to do like normal division, what you need to do is check all 1,000 numbers. You have to check 282, 682, 4682, 24682, 224682, blah blah blah, 1,000 times if you are at the 1,000 index. But if you use this technique, then you know that every single one of these 1,000 numbers are going to be divisible by 2. You don't have to check 1,000 numbers. You just know what is your own. You just need to know for yourself. You just add 1,000 basically. Does that make sense? Yes, for 1,000, same thing with 369, right? Let's say this is 3. So if you want, you can check 1,000, or you have a mod. You have a mod map that says there are 500 numbers before me whose sum is divisible. Sum mod 9 is blah. I think it's a mod map. It's basically a mod map of some kind. Yeah, yeah, it's basically a mod map. I think for 3, 6, and 9, you take the prefix sum. Yeah, you take like some kind of prefix sum, and then you do a mod map. And then for 7, I don't know. I think 7 is basically a simple mod. I think that's the way I'm gonna do it. Yeah. Okay. All right. Let's try it this way. Then I still have to go back to question 2, because question 2 is being a pain. Yeah, so the other sort of interesting thing I noticed is the input is string. The input is string, meaning, hey guys, treat this as a string, not as an integer. So that's a pretty big hint that we're not supposed to divide stuff. Okay, so 1 is every, 2 is every, 5 is every. And then 4 Okay, I see some more people in the chat. Welcome, welcome. Feel free to ask questions. If you, feel free to ask questions if you have any questions. If not, work on this yourself. And I guess have fun. That's all I'm gonna say. Okay. So force. Okay. Okay, so for force, for 3 and 6. Actually, interesting. Uh, Actually, I feel like 9. Okay. Damn. Actually, now that I'm doing it, I feel like the technique used for 7 can also be used for all other numbers. It's like a general technique. It's like a general technique. Yeah, you don't check all substrings. That's the point. You don't check all substrings. You want to have a ON operation. You don't want ON square. That's the whole point of this exercise. That's why you look at like, that's why when you see a 2, you don't have to check any substring, right? So if you see like when you get to point here, the index 1000, you see a 2 means that the total count is just plus 1000. You don't have to check every single substring. That's the whole point of it. Okay. Okay. So let's see. Uh 1, 2. So for 9 is going to 9 divisible by Okay. I think I got it. I just need to debug my code. So 1 1 Okay. 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3. Okay. So 1, 2, 3. Okay. I think I got it. I think I got it. Famous last words. Okay. I figured out the 3 and the 9. Okay, I figured out the 3 and the 9. Okay, let's see if this works. Case 2, 12. Oh, it's wrong. Oh, wait, case 1, 7. Huh, it's wrong. Dang it. Today's quiz is so hard. Why is this quiz so difficult? 3, 6. Oh, I haven't done 6 yet. Last digit divisible by 6. Okay. Okay, I'm stumbling a little bit. Okay, let's see where we're at. Okay. Yeah. Okay. So I got most of the numbers. I got 7. I think it's correct. I have a bug with this 369 because I tried to do some shortcut and it's, yeah, I tried to be clever about it. I try to be a little bit faster than I need to be. But it's turning out to be slower than I want it to be. Okay, so for 3s, let me see, for 8. Five seven zero 1 2 8 3 5701288. Five 7 0 5 7 0 1 1 2 3 4, yeah, 2 5 1 2 3 4 5. 8 is 1. It should be, yeah, I'm trying to debug something. I pretty sure it's I minus 1 times 10 plus I minus 2. What? Okay. get 6. Why is this 6? Oh. Okay. So I fixed the problem for 8. I got everything except 6. I got everything to work except 6 and 3. 6 and 9. How are you guys doing? How do you check our substring? Yeah, I'll explain again. Basically, yeah. Let me find the... Okay, so basically the idea is, if basically it's an index, right? I go through all the numbers. So let's look at 2. So I have a for loop. I go through each number. When I reach this number, let's say I reach this guy here, right here, right? Its index equals to, let's say, 100. Okay? If at index 100 I see a 2, everybody before this guy is divisible by 2, right? Any contiguous substring ending at this number is divisible by 2. How many contiguous substrings are there ending at this number? Well, its index is 100, right? So there's basically 100 minus 1, which is 100 plus 1, sorry, which is 101 substring. So it's basically this guy, 2, this 2, 2, 2, whatever before it, until 1, blah, 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 2. So same thing. If I see this is index maybe 150, right? I see this 2 here. How many numbers end with this at this index and are divisible by their last digit? Well, its last digit is 2. Basically, everybody who ends at this index is their last digit is 2, and everybody who ends with 2 is divisible by 2 by their own last digit. So if its index is 150, I know my total is just plus equals 151. So it's index plus 1. So 282, 682, 4682, 24682, they are all any contiguous sequence ending with this index is divisible by 2. So I don't have to have another for loop that goes through all of them and then do the division and do the mod and blah blah blah. Well, I don't have to do that. If I'm at index 150, I see that I end with the number 2. That means everybody before me, any contiguous string ending with me, is going to be divisible by 2. That's the basic logic here. So you can apply the logic to 1, to 2, to 5. Anybody ending with 5 is divisible by itself. 4, you have to check the one before. You have 4, you check the one before. Right? So the one before is 2. If I see the one before is 2, 4, everybody ending with 2, 4 is divisible by 4. So you can just say total equals total plus whatever my index is. So let's say this 4. So this 4 is at index 151. So I will know that because the number immediately preceding me is a 2 and 24 is divisible by 4, everybody ending with 24 is divisible by 4. So my total equals to total plus 152. I don't even have to check each of these one by one. So that's the basic strategy. So you use some trick to figure out. 3, 6, and 9? Yeah. Yeah, so for 3, 6, and 9, what you want to do is, what I did is I basically have a sum. I keep track of all the sums. All the basically prefix sums. So for instance, actually not just 3, 6, and 9. Even 7 works the same way. So let's say, let's start a new one. Let's say I have, my sequence is 5, 7, 0, 1, 2, 8, 3, right? So when I see a 5, let's say I have the mod of 3, 0, 1, 2. I see a 5. 5 mod 3 is 2. I say there's a 1. And then I see a 7. Okay, 7 mod 3 is going to be, what's 7 mod 3? Is a 1. But I know that this is 2. 2 plus 7 mod 3 is 0. So this becomes 1. So I know what I'm saying. Basically what I know is there are this number of sequences ending at this index whose mod 3 is equals to this. So when I reach here, I know there's one subsequence or one substring ending at this index whose mod 3 is equals to 0, and one substring ending in this index whose mod 3 is 1. So specifically 7 mod 3 is going to be 1 and 57 mod 3 is going to be 0. So now I go on to 0, right? So 0, yeah, so basically it's a bit of math. It's a bit of math. I'm going to show you the math later. I'm going to let you work out the math actually. See if you can understand. Yeah. Yeah. So WebSlick, hey, you got question 2? Very nice, very nice. I'll take a look at it later. Yeah, so that's the basic idea for question 3. You know, the tricky part is actually getting the code to work. So I'm still also getting the code to work. I hope I'm close. Maybe not. I have no idea. I got everything to work except 6. 6 doesn't work. So 1, 3, nice. Oh, okay. Okay, so I got it work on the test cases. And I am going to take a gamble. I'm just going to submit this and hope for the best. I hope I didn't have a bug. Yes, I managed to do question 3. Very nice. Okay. Back to question 4. Yeah, I feel like question 3, I probably can... You know, there's probably an even easier way to do question 3, but you know what? Whatever. I'll talk about the easier way to do question 3 later. I want to go back to question 2. 6 should be checked for 3 plus even digit at the end. Aha! So Maddox, if you are 6, if your current digit is 6, you already end with a 6. So you don't have to check that it's an even digit in the end. Your last digit is 6. So you know you're already divisible by 2. All you have to do is to check for divisible by 3. So you need some way of checking that the number is divisible by 3, divisible by 9, and divisible by 7. So 3 and 9, you can sort of use the same technique. You do like a mod of the sum of the numbers before them. And then for 7, 7, you do something else. Yeah, I will go through all of them later. I want to get question 2 first. I want to finish question 2. I think this contest is kind of hard. I'm a little bit angry about this. This is so hard. Even question 1 is hard. What the heck? Use map to one. Huh. Oh, you're done? You did all 4? Very nice, WebSlick. Well done, well done. Let me look at question 4. I can't figure out question 3, but let me look at question 4. You're given an array points of size n and an integer m. There's another array game score of size n, where game score I represents the score at the ith game. Game score I equals to 0 for all I. I have no idea what this is talking about. Oh man, I tell you, this is like 50% programming and 50% English reading comprehension. This is basically an English reading comprehension contest. You're given an array points of size n and integer m. Okay? That's it. There's another array game score of size n, where game score I represents the score at the ith game. You start at index 1, index minus 1. You can make at most m moves. In each move, you can either increase index by 1 and add game score. Okay, so you're at index 1. So the first thing you need to do is to go to index 0, points 2, and game score I to game score what is I? So initially index is 0. You index I is equals to 0. So increase this by games index 0, game score 2, you add to this. Okay? And then what do? Decrease index by I. Okay, you increase index. Okay, so basically your index is Websley, he's done, game over. Oh my god. Yeah, it's a what, bro? It is such a struggle. You know what, Websley, you did question 2. I couldn't do question 2. So, you've got that going for you. You know what? I'm gonna go back and look at question 2. I don't believe I can't do question 2. So question 2, let me see what you Webstick wrote. Hint question 2, use map to map the minimum mini dx of the elements in the elements array and go through all the groups array and apply divisibility check. So So you basically sort the elements array. Do you sort the elements array? Go through all the groups array and divide for d equals to 1. Do you sort the... Are you sorting the element? The minimum index of the elements in the elements array. The minimum index of the element in the element array. Go through all group array and apply divisibility check. To d equals to 1 to d equals to divisibility check. Wait, are you sorting them? How do you... Yeah, you yeah, that's why I'm curious too. Get the minimum index. So you're mapping you're doing something to elements, right? You're doing something to elements. Minimum index of the element in the elements array. So are you just removing duplicates? Is that what's happening? Wait, are you just removing duplicates? Minimum index of the element in the elements array. Let me think about it a little bit. So I don't get it. Oh. Wow, really? Wait, that works? All the multiple of groups I to 0. But how do you know what the multiples of groups I are? Am I reading the question right? The groups can be anything, right? So like if the first number is 8, you find out 8 is divisible by 0. Then how do you find out the multiples of 8? 8 has a lot of multiples. There's one. Yeah, am I missing something? The groups I can be anything, right? Divisible by elements I if the multiples. Damn. You don't check for multiples. Group I is divisible by index 0 of the array and make all the multiples of groups I to 0. Okay, let me think about it. Let me think about it a little bit. Because this groups is also very big. So if you're going to go through all the items in groups, it's gonna be slow. It's gonna be slow. Especially if all the items in groups are relatively prime, then it's going to be super slow. Okay. Because if groups yeah, do that. I'll love to. Yeah, thanks for definitely after the contest. Thanks for not sharing it during the contest. I got to think about this too. Something I'm not getting. Let me see. If groups I is divisible by element j. If groups I is divisible by element j, then everything in groups I, then anybody who is a multiple of groups I is also divisible by elements j. But you don't know who is the multiple of groups I. You don't know who is the multiple of groups I, and it takes a long time to find out. Yeah, third sum. Let me see. So third sum, the hint is on the board. Basically, for each digit, you do something a little bit different. You want to make sure that when you're at a digit, you know. Basically, when you're at a digit, you want to know how many numbers end with that digit, ending at this digit, are divisible by itself. So you can do something a little bit different for a digit. Actually, the trick you can use for 7 can be used for everyone. So if you can make the 7 work, you can do it for everyone. I'll go through it after the contest ends, since the contest is ending pretty soon anyway. It'll be easier for me to explain when I show you the code. Question 2. Yeah, I'm trying other things. Still timeout. Yeah, so Sriram Rajkumar, I'm going to explain it in full in a bit. Still time limit exceeded. For question 2, why am I doing this wrong? What am I doing wrong? Yeah, I don't think I'm finishing question 2. All right. All right. While I have everybody here, the contest is about to end. Usual spiel. If you enjoy my stream, click the like button on the video. It's gonna help me out. Leave a comment when the video comes out. That's gonna help me out. Like and subscribe to the channel if you haven't already. Tell your friends about the channel. I don't know if people actually talk to their friends about YouTube channels. I certainly don't. But if other people want to know, tell your friends about me. I'm just a small content creator trying to grow my channel. I'm going to take a swig of water. I'm going to come right back. And we are going to talk about the carnage. Sucknik Sansama messed this one up. Yeah, this is, you know what? You're not the only one. It is what it is. At the end of the day, as long as we're all learning, we're all getting better, life goes on, right? There's no incentive to actually get a very high rank. It's not gonna help you in your job interview. It's not gonna. Nobody's gonna look at your LeetCode rank and be and care. Yeah, it's literally just for fun. Yeah, most of these questions probably are not questions that people will ask in a real job interview anyway. It is the validation. Yeah, I know. This is the V word. Yeah, if anything, I should probably care more about my rank than you guys since I'm doing this YouTube channel thing. But at the end of the day, as long as we come week after week, we do some contests, we enjoy ourselves, we are all winners. Alrighty. Almost done. Okay, contest has ended. So let's go through the answers. Let me just do my usual spiel. We are discussing solutions for LeetCode Weekly Contest 436. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel. If you enjoy LeetCode content, like and subscribe to stay up to date on new videos. Specifically, if you like what I have, just click the like button on the video and leave a comment if you are watching the VOD. That will help me out a lot. All right, let's begin. So we're going to start with the first question. Sort matrix by diagonal. You are given question 1, sort matrix by diagonals. You are given an n by n square matrix of integers grid. Return the matrix such that the diagonals in the bottom left corner in the triangle, including the middle diagonal, are sorted in non-increasing. This just means decreasing. And the diagonals in the top right corner are sorted in non-decreasing, which just means increasing. So we want one direction to go down, one direction to go up. Essentially what we're doing here, we're going to divide the matrix into two. We have this side, which is the bottom left, and then the other side, which is the top right. So the bottom left triangle, including the middle diagonal, should be sorted in non-decreasing. Non-decreasing means non-increasing means decreasing. So 4, 9, 5 is going down, right? 8, 6, 1 is all going down. So top right corner is sorted in non-decreasing, which means going up. So 2, 7 going up, 3 is going up. Yeah. So that's the basic idea. So in order to do this, we actually don't have to move the matrix. We can sort it in place. Let me just get my code here. We can sort it in place. And the only tricky part is trying to figure out how to get the diagonals. You want a way of iterating the diagonals, right? Imagine if the problem, instead of talking about diagonals, is talking about rows. This problem is so simple. You just get all the numbers in a row, sort them, and then put them back. That's all. So you want to do the same thing. You want to first collect all the numbers in the diagonal. Let's say this middle diagonal, 1, 8, 6. You want to collect 1, 8, and 6. You want to sort them to 8, 6, and 1, and then you put them back exactly the order we found them. That's the basic idea. So the only tricky thing is finding a way to iterate over a diagonal. here's a useful property that you can remember, right? For those of you who solved it already, you probably already know. So for diagonals going in this way, top left to bottom right, basically your x minus y equals a constant. So the difference between your x and y is a constant. So this middle diagonal, x minus y equals to 0. So x is, let's say, 0, 0, 1, 1, 2, 2. So this diagonal here, x minus y equals to 1. So x is, let's say x is going down. So this 1, 0, and then 2, 1. So x minus y equals 1. And this diagonal, x minus y equals to 2. So you can sort of find which diagonal you are by calculating the difference between x and y. So when the difference at x and y is 0, then you have the middle diagonal going from top left to bottom right. If the x minus y is 1, then you have this diagonal over there to the left of the middle diagonal. If x minus y is minus 1 here, x minus y equals to minus 1, then you have this diagonal over here. So that's the basic idea. So this difference can go all the way from plus to minus n. Plus to minus n, where n is the width of the matrix. So that's the basic idea. So basically what you want to do is you want to say, okay, so from, let's call this difference x. Let's call this difference d, right? For d equals to 0, which is this middle diagonal, I want to find all the grids, all the squares that correspond to d equals 0. Sort them and then put them back. So this is what I'm doing here. This is the first thing I'm doing. When d equals to range 0 to n, because this is going this way, right? 0 to n. I equals to x plus d, j equals to x. So I is equals to x plus d, and j equals to x. So when d equals to 1, when d equals to 0 is this central one, j will be 0, 0, 1, 1, 2, 2. When d equals to 1, which is this guy over here, d equals to 1, this diagonal here, then ij will be 1, 0, 2, 1, 3, 2, etc. So the difference between I and j is going to be 1. So so basically you have two for loops here. The first for loop, you have actually three for loops here. The first for loop iterates over the diagonals, all the diagonals. And for each diagonal, I find the I and j. I collect all their values into this array here. I sort the array reverse, because that's what the question asks, and I put them back exactly how I found it. That's the basic idea. So this piece of code handles the bottom left triangle. This piece of code handles the top right triangle. The only difference is that I'm sorting in reverse. And also here I'm doing x plus d. Here I'm doing j equals x plus d. So I'm going this way. So this is a nifty trick for finding all the diagonals going from top left to bottom right. If in the future you need to find diagonals going this way, then you need to do x plus y equals a constant. So x plus y equals to 0 will give you this. X plus y equals 1 will give you this. So on and so forth. So that's how you iterate over diagonals. Once you find a way to iterate diagonals, the rest should be quite straightforward. Okay, let me check if there are any questions. Yeah, so this is insanely hard for question 1. I don't even know why it's here. Okay, so I'm going to now jump to question 3, because question 2 I didn't manage to get it. So I'm going to jump straight to question 3. Okay, so question 3, count substrings divisible by last digit. You're given a string S containing consisting of digits, return the number of substrings of S divisible by their non-zero last digit. So a substring is a contiguous non-empty sequence, and substring may contain leading zeros. So essentially, we want to return the number of substrings as divisible by the non-empty last digit. So essentially, what we want to do is the substrings. Let's talk about substrings first. So substrings of 12936 will be 12, 129, 293. Any contiguous sequence within this string is considered a substring. 36 is a substring. 93 is a substring. 129, 29, they're all substrings. Okay? So what you want to do is you want to count how many of them are divisible by their own last digit. So you do it the brute force way, it's going to be n squared. And we know 10 to the power 5 n squared is not going to work. It's not going to work. So we need a better way of counting how many numbers there are. How many substrings there are that end with their own last digit. So what we want to do is we want to essentially go down this sequence, and when we reach an index, we want to say, okay, how many numbers end at this index and are divisible by its last digit. So let's say the example is 12936. We start with 1 first. We say 1. Okay, how many numbers end at this index and are divisible by 1? Well, there's only one number that ends with this index, so it's 1. What about 2? How many numbers end with 2 at this index and are divisible by 2? Well, we know that all numbers that end with this index is divisible by 2. So it's 1 is going to be 2 and 12. And so on and so forth. So that's the basic idea. 9. Okay. How many numbers end with this 9 and are divisible by 9? Well, this is kind of hard. One way is to go look at all the numbers, right? 9, 29, 129. That's going to be n squared again. So we don't want to do that. So instead, we need a fast way of finding out. But I'm going to put a pin in that first. 3 and then 6. Okay, so basically what we want to do is when we reach an index, we want to have a like a linear time or some super duper fast way, not ON time, of finding out how many numbers end at this index and are divisible by that digit at the index. That's the question we want to ask. So how do we want to do this? Well, if let's say I have a sequence, right? 1, 2, 6, 9, 0, 1, 3, whatever, blah, blah, blah. Let's say I have a very long sequence. At a certain index, I see the number 1. Okay? How many, let's say there's a 1 here. If I'm here, how many numbers at 1, how many numbers end with this index and are divisible by 1? Well, I don't have to look at every single number before it. I know this index is, let's say, 500. I know that 501 numbers are divisible by 1 because every single substring that ends with this 1 is divisible by 1 by definition. So if I end with 1, then is just my total is just index plus 1. If I end with 2, let's say this number is 2, how many numbers, how many substrings end at this index and are divisible by 2? Well, basically everybody who ends with this index ends with 2. And any number that ends with 2 is divisible by 2. So it's also index plus 1. And we do this for every single digit. Every single digit has its own special rule. 6, 7, 8, 9. And 0 we ignore, right? We ignore 0. So for 5, it's the same, index plus 1. Because everybody who ends with 5 is going to be divisible by 5. We know that. For 4 and 8, we have to look at the number before. So let's say this number is 4. That's a very shitty 4. 4. So once again, the reason why we want to do this is because if we end up at this index, this is already a linear time algorithm, right? This is a linear time strategy. If we, within that loop, we have to check every number before it. It's going to be n square. It's going to be quadratic. It's going to be O(n) square. So that's going to be too slow. Within the loop, we need a like an O1 time. Instantly tell us how many times, how many substrings end at this index and are divisible by the number. So we need a fast way of doing that. So for 4, basically you look at the number before. If the number, okay, this number is 9, right? So it's going to be just 1, just itself. If the number is, let's say, 2, then everybody before 4 is going to be divisible by 4. So look at the previous number. So the reason why this is the case is because 100 is divisible by 4. So everybody before here doesn't matter. You just look at last 2 digits. So 8 is the same idea. You look at the previous 2 digits. Now 3, 6, and 9. Well, basically you need a way to tell whether how many substrings are divisible by 3, 6, and 9. So I'm actually going to do this the same way I do 7. 7 is very tricky. There's no shortcut for 7. So basically what I do is basically maintain a mod map. And I'll explain what a mod map is. What I want to do is I want to count how many substrings at any point. I want to know how many substrings end with this and are divisible by, let's say, 3. So let's do a mod map for 3. So there are only 3 possible mods. Anything mod 3 will be 0, 1, or 2. Where at the first number, one mod 3 is 1, and the other 2 are going to be 0. Okay, when you're here, the mod map for 3 is 0, 1, and 0. When you're here, this 2 mod 3 is going to be 2. Okay, at the same time, this 1 times 10 plus 2, it doesn't matter what it was before. It doesn't matter what the actual number is. This 1, anything that, you know, I know there's one number when divided by 3 has remainder 1. Okay, so if I take those numbers, I multiply them by 10 and divide that by 3, I'm going to get a mod of 0. So this 0 goes to here. It goes to 1. And again, the reason is because I know there's one number so far in this sequence who's when there's basically one substring who, when you take a remainder of 3, divide by 3 will give remainder 1. So if I add a 2, add this 2 to that substring, I have 1 times 10 plus 2. Okay, and this gives me 12. And 12 mod 3 is going to be 0. So this goes to here. Okay, so after the second digit, my mod map becomes 1, 0, 1. So now my third digit is 6. So everybody who was divisible by 3, anybody who divide by 3 remainder is 0, 1 now will still be 1. Anybody who, when divided by 3, remainder 1, now I'm going to add 6 to it. So this will be 1 times 10 plus 6 equals 16. 16 mod 3 is going to be 1. So this is going to be 1. And likewise, this is going to be 2 times 10 plus 6 mod 3 will be 2. So after this digit, again, this is 101. So the basic idea is at any one point. So what does 101 means? And I also add 1 because of the 6. So it's going to be 201. So what does 201 mean when you're here? Basically, it means that there are 2 substrings who, when divided by 3, will give you a remainder of 0. This guy and the whole thing, 126. And there's 1 substring, when divided by 3, will give me remainder 2, which is this 26. So basically, I'm going to do this. I'm going to keep doing this, building this mod map. When it doesn't matter what number it is, I keep building mod map. When I reach an actual 3, okay? When I reach this actual 3, how many numbers, how many substrings are there that end with this 3 and are divisible by itself? Well, it's just this 0 here. So that's what I'm going to do. So this mod map for 3 will tell me who's divisible by 3. So if you look at 3, 6, and 9, there's a funny, interesting thing, which is you can combine all their mod maps together because they are all multiples of each other. So you only need a mod map for 9, and you can figure out the other 2 for 3 and 6 based on that. And 7 will have its own mod map. So basically the answer, the way I wrote my code, looks a little bit like this. I have a mod map for 9s. I have a mod map for 7. I keep a running count, which is total. For every integer, every digit I see, I will update the mod map. I'm updating the mod map for 9, exactly how I did before. And then update the mod map for 7, exactly how I did before. Right? The digit itself, mod 7, you see one extra instance of that. And then for each of the rows, all the different mods of 7, 0 to 6, you do some math here. This is a new mod plus the old mod. Okay? And then here's the more interesting part. I check what digit I am. If I'm at digit 0, I pass. If I'm digit 1, I'm just index plus 1. I don't even have to go through everybody before that. I know if I'm at index 500, that means there are 500 numbers that end with 1. They are divisible by 1. Same thing for 2. For 3, I take the mod map of 9. I look at all the mod maps of 9 where their remainder is 0, 3, 2, or 6. For 4, I'm going to look at the digit before. For 5, is everybody. 6 is going to be same thing. Is a mod map of 9. I just need to check, is it divisible by 3? If it is, then I'm good. 7, I'm going to look at a mod map for 7. And 8, I look at last 2 digits. And then I return total. Now, if you look at this, actually, this mod map idea can be used not just for 7 and 9. You can use this for every single number. So instead of having two mod map for 9 and 7, and everybody else using these kind of tricks, I can create a mod map for all 10 digits. That would also work. That would be a little bit slower. That would be a little bit slower because I'm maintaining the mod map for things like 2 and 4, which I really don't need to. But it still works. And I'm pretty sure that will not time out either. Because it's the, what you call it, order of magnitude is like 100 times n. Whereas my order of magnitude is 2 times n. So, you know, it's basically the same. It's still linear time. Okay, let me look at the chat a little bit. How many are done pro? Bro, Comsci, welcome. I think I remember you. Yeah, I did 2. WebSlick also did 2. Yeah. Enumerating the factors in Q2 actually works. Shaking my head vigorously. Okay, can you guys send me your code? Yeah, WebSlick, I'm very interested in your code. So by enumerating the... Okay, let me come back to question 2. Go through question 2. Okay, let's talk about question 2. So question 2 is assign elements to groups with constraints. You are given an integer array groups where groups I equals to the size of the ith group. You're also given an integer array elements. Your task is to assign one element to each group based on the following rule. Excuse me. An element j can be assigned to a group I if groups I is divisible by elements j. If there are multiple elements that can be assigned the element with the smallest index. So the example is here. So 8, 4, 3, 2, 4. So for 8, I'm going to check. Is 4 divisible? If 8 divisible by 4? Yes. So it's 4. Is 4 divisible by 4? Yes. Sorry, you're supposed to store the index. So here are the groups and here are the elements. So 4 is divisible by 8 is divisible by 4, so it's index 0. 4 is divisible by 4, so it's also index 0. 3 is not divisible by any 1, so it's minus 1. 2 is divisible by 2, so it's index 1. And 4 is divisible by 4, so it's index 0. So the answer is 0, 0, minus 1, 1, 0. So that's the basic idea. Yeah, as for how to make it fast, I don't actually know. So the way I did it is I have a cache. I basically do memoization. When I go down the list, I check, have I seen this element before? If I've seen the element before, I put it in my cache. Basically, ignore this part. If I've seen the element before, I put it in my cache. If I've not seen the element, then I go down all the if I've not seen that group number, I go down all the elements and find the first one that fits my criteria. I set my answers to that and I break, and then I keep it in the cache. So this one didn't work. Unfortunately, this one gave a timeout. So I'm not sure what's the. Yeah, so I don't know what the better solution is. So I also tried the other way, which is I get rid of all the elements that are larger than the one before. So that doesn't work either. Yeah, so I'm not super sure what's the best way of doing it. This one got a timeout. So if you have an answer, definitely factorization for each works. So you're doing factorization for this, for groups or elements? Oh man, this is such a messed up. You're doing factorization. So basically you're saying for each group, you go through from 1 to 10,000 or 1 to the max of elements. You find out which you find out which one of them work. How is that faster though? I don't get it. How is that faster? That's also n square, right? That is also n square, right? A web stick, I can't see your link. So n square root x. N square root x. Man, really? That's faster? I don't see how it's faster though. Yeah. Okay. If you know what? If you can find out, you can link your solution. You can actually link your solution. How do I do this? You have to go to the problem. Yeah, basically what you do is you take out this. You take out this. Yeah. And then you go under submission. And then you can link your submission. Yeah, you can actually link your submission. Yeah, using this. So you take out this part. You take out this part from the URL. So you're not in the contest mode, you go the regular URL. You click on your submission, you copy link here, and then if you can paste that in the chat or paste that in the video comments, I will be much obliged. I want to take a look. I'm very curious about this. I still don't quite understand why it's faster. Maybe there's something I'm not getting. Yeah. Okay, let me just look at the last question. I didn't manage to do the last question. I didn't even get a chance to try it. But let me just go through it to see what it's look like. And maybe I'll talk a little bit about what my intuition is. So question 4, maximize the minimum game score. You are given an array points of size n and integer m. There's another array game score of size n. Okay, at the beginning, game score is all zeros. So you start at index -1, and you can make at most m moves. Each move, you can either increase the index by 1, add points I to game score I, or decrease the index by 1 and add points I to game score I. Okay, so basically, so points is length 2. If points is length 2, then game score is also length 2. Game score is also length 2. So what you want to do is you want to basically is sort of like this, right? 2 and 4. This is the points. So you imagine you're a guy. You can walk around this array. Actually, let's make this bigger. Is there a larger example here? Okay. So let's say points are 1, 2, and 3. Okay. So basically, you're a guy. You start from here, and then you can sort of move one step each. And you can go left and right, or left or right, and you keep going around game score. And the idea is at the end of the time, the m steps. At the end of m steps, let's say m is 5. You can go from here to here. There's 1, 2, 3, 4, 5. Okay, and your total score is the number of times you have visited each node multiplied by the value of the node. So this is going to be 2. 2 dots, 1. 2. 2 dots times 2 is 4. 1 dot times 3 is going to be 3. And your minimum game score is 2. So you're looking at the smallest number among these games, and you want to maximize this smallest number. That's the strategy. Okay, so I think this is some kind of DP, yeah, no? This is some kind of DP. Looks like some kind of DP. It looks like some kind of DP. It looks like a 2-dimensional DP problem. Points M. Whoa, hang on. No, it's not a DP problem. Wait, no, hang on. M is 10 to the power 9. Okay, it's not a DP. I thought it's a DP where you sort of figure out, if you're here, what's the best possible configuration. But it cannot be DP because you cannot have a linear time solution. A DP will be a DP solution will be at least OM or more. I think a DP will be exactly OM, if I'm not mistaken. But because M is 10 to the power 9, you're not gonna succeed. This is way too big. So basically, I think the other way, if you don't want DP, then the other intuition I have is, I think if I'm playing this as a human, what I'll do is I'll go to the smallest point node as many times as possible. I want to be at this node as often as possible. You see how I'm like bouncing between these two nodes? Right? Because this is very small. I need to get this to be as high as possible. If I don't visit this node often enough, then this minimum would be too low. Yeah, that's my general guess for what I can do. Yeah. As for what the actual algorithm is, I don't know. I have to think about it a little bit. Well, if somebody has the answer, make sure to let me know. WebSlick, no, I don't see your link. Do you copy and paste the link? You can paste it in chat or put in the comments. I'll take a look. If not, actually, probably what I can do is just look at somebody's answer. Yeah, I'm sure somebody has submitted the answer by now. Or I can actually look at these guys. Yeah, so the problem with these guys is their code is so hard to read. I really hate reading their code. Let's look at these guys. Okay, this is what you mean by factorization, right? Oh, this is what you mean by factorization. So this is the part I don't get. This is the part I don't understand. This is O(n) square. Just this loop here is O(n) square. How do you get it to work? This is O(n) square already. Yeah, because when I is small, when I is like 2, I don't know. I guess it's smaller than O(n) square. It's like O, and yeah. Yeah. Yeah, I unfortunately don't share my LinkedIn here. Yeah, yeah, sorry about that, WebSlick. I generally don't combine my web streaming persona and like my legit LinkedIn persona. The reason for that is because I don't see this live stream as a kind of job. So it doesn't actually go onto my resume, and I'm trying to decouple these two things. Maybe one day if I become right now I'm not very successful at a live stream, but if one day I become a more legitimate YouTuber, more successful YouTuber, then I start adding that on my LinkedIn, then I'll be more willing to sort of combine those two worlds and share my LinkedIn profile. Otherwise, yeah, sorry, I'm not able to do that right now. Yeah, but thanks for asking, and also thanks for coming to the channel. Yeah, I think you guys are right. Worst case, n times square root of n. So it's better than O(n). It feels a little bit O(n), but yeah. Yeah, I see how it can be better. Okay. All right, so I think this is the end of the live stream for today. Thanks so much to everybody for coming. Remember, it doesn't matter what your actual score is, as long as you're coming back week after week, you're learning something, you're trying to work on these problems. I think that you're all winners. So either way, this is basically the end of the live stream. Thanks so much for being here, and I'll see you guys next week. Next week, I'm going to be doing the bi-weekly contest. So that's on Saturday. Bi-weekly contest on Saturday. So I'll see you all next Saturday. Adios.